Question number 3. Two cylinders A and B are connected by a tube of negligible volume. Cylinder B has a constant volume of 1.6 times 10 to the power of 3 cm cubed and contains 0.2 mole of gas, while cylinder A have a volume of 2.5 times 10 to the power of negative 3 cm cubed, and initially cylinder A is at 300 Kelvin and the pressure of cylinder A and B are 3.4 times 10 to the power of negative 3.4 times 10 to the power of 5 Pascal and 4.9 times 10 to the power of 5 Pascal respectively. Then the tap between the cylinder are open. The total pressure of the connected cylinders is 3.9 times 10 to the power of 5 Pascal. So no thermal energy enters or leaves the gas. Determine the final temperature of the gas. Right. So for this question, you need to be able to imagine how does it actually look like. So I'm just going to illustrate for you. So you have two different cylinders. So you have cylinder A connected to cylinder B. Right. So here you should have like a pipe to connect it together. So in cylinder A, so I will just label this one A and this one B. So cylinder A is 2.5 times 10 to the power of 3 cm cubed, and then it states that it is at 300 Kelvin and the pressure inside here is 3.4 times 10 to the power of 5 Pascal. On the other hand, for cylinder B, the size is actually 1.6 times 10 to the power of 3 cm cubed, and then the number of mole is given to you already, 0.2 mole, and the pressure is 4.9 times 10 to the power of 5. Right. Okay, so what you need to do is that you need to convert all the units so that you can get to calculate the thing that you want to calculate. So at the moment you will ask to calculate the final temperature of the gas. Right. So basically at first it was at 300 Kelvin, right? So we are going to look at cylinder A first. So cylinder A, the pressure is 3.4 times 10 to the power of 5 Pascal. So you need to convert this to APM. So how are you going to do that? It's going to do 1 over 1.013 times 10 to the power of 5 times this value, 3.4 times 10 to the power of 5. So you shall get 9.8717 times 10 to the power of negative 6 times this one, 3.4 times 10 to the power of 5. So you should get 3.3564 APM. Okay, this is the pressure for cylinder A, and then what you need to convert is the volume. So the volume is in centimeter cube, right? So in centimeter cube, so you need to convert it to liter. So what you need to do is that because centimeter cube is equivalent to milliliter, so you just have to divide it with 1000. So 2.5 times 10 to the power of 3 divided by 1000. So it should be equivalent to 2.5 liter. Alright, so from here, actually you have enough information already to find what is the number of mole of gas inside container or cylinder A. So we are going to use PV equivalent to nRT. So PV equivalent to nRT, your P is the one that you have calculated just now. So your P is 3.3564. Your V is 2.5. The N is the thing that you want to calculate. So R is constant value 0.0821, and your T is actually 300 Kelvin given in the question. So you need to calculate it properly. You should get your N equivalent to 0.3407. So another thing that most of you did is that you just calculate like this. So you are going to miss 1 point because you need to show me how you get to N. So you need to write 8.391 divided by 24.63. Then only you give me the final answer. So you already get the number of mole for cylinder A, which is 0.3407. So given in the question, the number of mole in cylinder B is 0.2. So what we can do is that we need to calculate what is the total number of mole. Total number of mole means the number of mole for A plus number of mole for B. So the number of mole for A is 0.3407. Number of mole of B is equivalent to 0.2. So the total shall be equivalent to 0.5407 mole. Okay, this is the total number of mole of gas. When the pipe is being open, means that the gas will mix together. So the total number of mole of gas shall be this one, 0.5407. So what about the total volume, right? So the total volume, we need to calculate the total volume as well. So volume of A plus volume of B. So volume of A we already calculated is 2.5 plus volume of B. So this one we need to convert to liter. So 1.6 times 10 to the power of 3 divided by 1000. So you shall get 1.6 liter. So plus 1.6. So the total volume shall be 4.1 liter. Okay. So since you already have the total number of mole and the total volume, and you know that what is the pressure, if you can see again the question. So from the question we can see that and the pressure of cylinder A and B is this one, and then it states that the total pressure of the connected cylinder is equivalent to 3.9 times 10 to the power of 5 Pascal. So the total pressure is given in the question, which is 3.9 times 10 to the power of 5 Pascal. So this one you need to convert to ATM. So how are you going to do that? Is just by dividing this value with 1.013 times 10 to the power of 5. Therefore you should get this is equivalent to 3.8499 ATM. So this is the total pressure when this pipe is being open, means that all these gas are released to mix together. So this is the pressure. So you already have number of mole, you have volume, you already have the pressure. So definitely you can use the ideal gas law again to get what is the temperature, because you already have N. So like PV equivalent to nRT, you already have P, you have V, you have N, So definitely you can find the value of T. So following up of all the values that we have, so total number of mole is equivalent to 0.5407, and then the total volume is equivalent to 4.1 liter, and then the total pressure. These are all from the calculation we have just calculated, equivalent to 3.8499 atm. Alright, so from all these values, we just need to plug into the ideal gas law formula, PV equivalent to nRT. So your P is 3.8499, your V is 4.1 liter, N is 0.5407, R is constant 0.0821, therefore you can find the value of T. So your T shall be equivalent to 15.7846 divided by 0.0444. Therefore, you shall get T is equivalent to 335.5088 Kelvin. Right. But in the question, the temperature given to you is in degrees Celsius, so you need to convert this back to degrees Celsius. So 335.5088 minus 273, you shall get 82.5088 degrees Celsius. So this is the final answer for this third question. Question number 4, the last question that we will discuss covering the first chapter. So, blast furnace give off a mixture of carbon dioxide and hydrogen sulfide. The total air pressure and the partial pressure of carbon dioxide is 0.83 atm and 0.25 atm respectively. So what is the mole fraction of hydrogen sulfide? So this is a partial pressure question. So what you can do is that we have this gas mixture. So we have carbon dioxide and also the hydrogen sulfide. Okay, so the total pressure given in the question is equivalent to 0.83 atm. Right? See, the total pressure is 0.83 atm and the partial pressure for the carbon dioxide is actually equivalent to 0.25 atm. So you were asked to calculate what is the mole fraction for the hydrogen sulfide. So since you know the partial pressure for the carbon dioxide, since we only have two different gases, so pressure for carbon dioxide plus pressure means that partial pressure for hydrogen sulfide is equivalent to total pressure, which is 0.83. Given in the question is that the partial pressure for carbon dioxide is 0.25. So partial pressure for hydrogen sulfide is equivalent to 0.83 minus 0.25. So you shall get 0.58 atm. Okay, this is the partial pressure for hydrogen sulfide. But if you look back at the question, you were asked to get the mole fraction. So what is the mole fraction of this thing, the mole fraction? So you need to recall back what is the formula for the mole fraction, right? Okay, so from here we can say that the partial pressure of a gas is actually equivalent to the mole fraction times total pressure. So since you know the partial pressure is 0.85 atm, so you can actually find the mole fraction, which is this one. You bring down there. So because the total pressure given in the question is 0.83, so 0.58 divided by 0.83, therefore this you shall get the mole fraction. The formula for partial pressure is mole fraction times total pressure given to you. The total pressure is 0.83 and the partial pressure for the hydrogen sulfide is 0.58, so you just need to divide this together. You will get the mole fraction for the hydrogen sulfide equivalent to 0.6988. So this is the final answer for the last question, question number 4 for chapter 1.